All right, Chapter 4, Antennas. Navy Electricity Electronic Training Series, Module 10, Introduction Wave Propagation Transmission Lines, Antenna, Navy, and NAVEDD, TRA 14812. Distribution Statement, blue for public employees, distribution unlimited. A little bit overshot it. All right, Chapter 4, Antennas. Chapter 4, Antennas. Learning objective. Upon completion of this chapter, you'll be able to save the principle of the antenna radiation. Let's wrap the antenna to explain the current voltage distribution of the antenna. Describe how the electromagnetic energy is radiated from the antenna. Explain polarization, gauge, radiation-resistant characteristic of the antenna. Describe the theory of the operation of half-wave, quarter-wave antennas. List various array antennas. Describe the directional array antennas presented. Explain the basic operation of each. Identify the various special antenna presented, such as long wire, V, or rhombic, tonsile, ground plane, corner reflector. Describe the operation of each. List safety precautions for the working aloft the round antennas. Introduction. You have been around in the early days of electronics. You have also considered the antenna or aerial to be little more than a piece of wire strung between two trees of upright pole. In these days, the technician will assume that the longer antennas automatically provide the better reception of the shorter antennas. They are believed to be mysteriously medium-filled all spaces that an antenna use the medium to send the received energy. To the assumption, since they have been disregarded, the modern antennas have evolved to the point where the highly directional, specially designed antennas use the relay worldwide communications space throughout the use of the satellites. Each Earth station antennas present the transmission theory that present that are based on the assumption that the space itself is the only medium necessary to propagate the transmission of radio energy. All right, show the sunlight, satellite, solar panel, satellite, orbit, 6 gigahertz uplink, 4 gigahertz downlink, cone satellite covered Earth stations. A tremendous amount of the knowledge and information has been gained about the design of the antenna of the radio wave propagation. Still, many old-time technicians will tell you when it comes to designing the length of the antenna, the best procedure to perform the calculation and try out the antenna. If it does not work, use and cut and try method until it does. Fortunately, enough information has been collected over the last few decades that it is now possible to predict behaviors of the antenna. The chapter will explain the basic design and operation of the antennas. Principle of the antenna radiation. After the radio frequency signal has been generated with the transmitter, some of the means use the radiate the signal through the space to a receiver. The device that does this job of the antenna. The transmitter signal energy it is sent into the space. The transmitting antenna of the radio frequency signal is then picked up from space by a receiving antenna. The radio frequency energy transmitted within space in the form of the electromagnetic field. The traveling electromagnetic field arrives at the receiving antenna. Voltage induced into the antenna of the conductor radio frequency voltage induced for the receiving antenna that are passed the receiver that converted back into the transmitted radio frequency information. All right, the design of the antenna series is very important for the transmitting station. The antenna must also be able to radiate efficiently so that the power supply of the transmitter is not wasted. Efficient transmitting antenna must have the exact dimension. The dimensions are determined by the transmitting frequency. The dimensions of the receiving antenna are not critical for the relatively low frequencies. However, as frequency of the signals become received and increase, the design installation of receiving the antenna becomes more critical. Example of these television receiving antenna. This is if you raise a few or more inches to the ground, give it a slight of the direction, you can change the snowy blur into a clear picture. The conventional antenna of the conductor system of the conductor of the radiation, the intercept with electromagnetic wave and energy. The ideal antenna with a definite length with a uniform diameter, the completely isolated place in space. However, the ideal antenna is not realistic. Many factors made a design of the antenna of the communication system is more complex problem that you would expect. The factors include the height of the radiator above the Earth, conductivity of the Earth below, and its shape, the dimension of the antenna. All these factors affect the radiated field, the pattern of the antenna in space. Another problem, the antenna designs a radiation pattern of the antenna must be directed between the certain angle of the horizontal, vertical plane, or both. Most practical transmitting antennas are divided into two basic classification. Hertz or half-wave antennas or macaron quarter-wave antennas. Hertz antennas are generally installed with the sum of the distance above the ground with the position to radiate either vertically or horizontally. Macro antennas operated one end of the ground. One are mounted perpendicular to the earth or to the surface. They're acting as a ground. Hertz antennas are generally U with the frequency of above 2 MHz. The macron antennas and antennas are U with the frequency below 2 MHz, maybe U with the higher frequency with certain applications. A complete antenna system consists of 3 parts: a coupling device, a feeder, and the antenna. The shown figure 4.2 with a coupling device, coupling coil with a connectivity transmitter to the feeder. The feeder is a transmission line with a carries the energy to the antenna. The antenna radiates the energy in space. Figure 2.4.2 will show the typical antenna system: the feeder, the antenna, coupling, transmitter, antenna. The factor determines the type of the side of the shape of the antenna. Figure 1 with the frequency of the operation of the transmitter, with the amount of the power to be radiated, the general direction of the receiving set, with the type of the antenna shown in figure 4.3. Alright, you have your waveguide horn with a dish, ground screen antenna, folded dipole, ordinary dipole, Yagi antenna, your ground plane, long wire, antenna counterpoise, ultra high frequency antenna with a counterpoise, satellite antenna, earth station antenna. Alright, current and voltage distribution on an antenna. The current flowing over the wire whose length is properly related to the radio frequency produced with the electromagnetic field. The field is radiated with the wire with the set with the radius space. We'll discover these waves are set for you later in the chapter. Remember, the principle of radiation and electromagnetic energy are based on the 2 laws. The moving electrical field creates the magnetic field, and the moving magnetic field creates an electric field. In space, the 2 fields will be in a phase perpendicular to each other with any other at any given time, and although the conductor usually considered to present the moving electrical magnetic field is mentioned in the laws govern these fields are saying nothing about the conductor. Therefore, thus the law holds true whether the conductor is present or not. Figure 4.4 shows the current and voltage distribution halfway or hertz antenna. The figure view A, the piece of the wire. In view A, the piece of the wire was cut off and cut in half. They attached for the terminal of the high frequency of the AC generator. Figure 4.4 show the current and voltage distribution of half-wave hertz antenna. In view A, the piece of the wire is cut in half, attached for the terminal with a high frequency AG generator. The frequency of the generator is set with each of the half of the wire, the quarter wavelength of the output. The result of the common antenna is known as the dipole. Alright, you have a half-wave antenna, your direction of the current flow with the current distribution over the curve. Current distribution, your charge and distribution, electrons, negative charge, positive charge. At a given time of the right side of the generator is positive, the left side of the negative. Remember, the like charge of the repel. Be careful, the electrons will flow over the negative terminal as far as possible. They will be attracted to the positive terminal in view B. Show the direction of the distribution electron flow with the distribution curve. Show the most of the current flow over the center. No flow at the end of the current distribution over the antenna will always be the same, no matter how much or how little the current is flowing. However, the current at any given point on the antenna will vary directly with the amount of the voltage developed on the generator. 1/4 cycle after the electrons have begun with the flow of the generator will develop the maximum voltage. Current will decrease to 0 at the time of the condition shown to UC will exist. No current will be flowing. The maximum number of electrons will be at the left hand end of the line, and the minimum number at the right end. The charge of the distribution of UC along with the wire will vary as long as the voltage of the generator voltage, therefore may distribute, draw flowing. Following conclusion. 1. The current flow of the antenna amplitude will vary with the generator voltage. The residual distribution charge exists on the antenna for every 1/2 cycle of the charge reverse of the polarity. Residual variation in the charge magnitude lags residual variation in the current 1/4 cycle. Radiation, electromagnetic energy. Electromagnetic radiation from the antenna is made up of the 2 components of the electric field, the magnetic field. We discussed the field of chapter 1 and 2, the 2 fields occur with 90 degrees out of phase. Each of these fields are added and produce a single electromagnetic field. The total energy of the radiated wave of the rain is constant with the space, except for some of the absorption of the energy of the earth. However, the wave of the advanced energy speed over a greater area at any given point, the degree of the distance of it increases. Various factors of the antenna circle the effect with the radiation of these waves. In figure 4.5, an example of the alternating current is applied with the A end of the length of the wire, and A to B of the wave will travel along the wire until it reaches the B end. And since the B end is free, the open circuit that exists for the wave of the current cannot travel farther. The point of the higher impedance of the wave bounces back, the reflective of the point of the higher impedance to travel toward the same point, but the reflective of the energy of the wave would gradually dissipate with the resistance of the wire back and forth with the motion and oscillation. However, each of the starting point, the wave is reinforced by an amount with a sufficient replay for the energy level. The result of the constant oscillation of energy longer the wire and higher voltage at the end of the wire, the oscillation applied with the antenna require rate equal to the frequency of the high radio frequency voltage. So the oscillations are applied to the antenna at the rate to equal the frequency of the radio frequency voltage. You have a radio frequency source, A, B, one half length, Y with the antenna's radio frequency source. The impulse of it must be properly timed to sustain oscillation for the antenna. The rate of which the wave that travels along the wire is constant, approximately 300 million meters per second. The length of the antenna may be such a wave that travels on one end of the other, but back again during the period of one cycle of the radio frequency voltage. Remember that the distance of the wave traveled during the period of one cycle is known to the wavelength is found with the divided of the rate of the traveled by frequency. All right, look at the current voltage of the chart of the distribution of the antenna. Figure 4.6 with the maximum move of the electron center of the antenna at all time. Therefore, the center of the antenna is at the low and pivot conditions called the standing wave. With the current, the point of the high current, the high voltage known with the current, the voltage loop. With the point of the minimum of the current, minimum the voltage known with the current, the voltage nodes. Figure view A show the current loop of the start of the nodes. View the B show the voltage loop of the voltage node. Figure view C show the result of the voltage of the current loop of the nodes and present of the standing wave that describe the condition of the resonance in the antenna as the resonance wave that travels back and forth. The antenna receiving each of the electromagnetic waves are transmitted into a space called the maximum radiation. At the maximum radiation, when the antenna is not at resonance, the waves tend to cancel each other out and lose the energy form of the heat. Alright, show the node and the node of the antenna, the loop, and then it has the loop and the antenna, the voltage, and then it shows the current and the voltage, the loop, show the of the node and the antenna, and the voltage of the node and the loop. Alright, antenna character for the unify of the antenna for the conductor group of the conductor of the either radiating electromagnetic energy in the space, we're collecting it from the space, electrical energy for the transmitter converted with the electromagnetic energy by the antenna for the radiated into space on the receiving end of the electromagnetic energy of the converted with the electrical energy by the antenna of the fed, but the receiver, fortunately separate antenna seldom require the both transmitting and receiving the radio frequency energy with the an antenna can transfer the energy of the space input with the receiver the same efficiency with the transfer of the energy from the transmitter into space. Of course, they assuming the same frequency as you, the both the cave the proper and property of the interchangeable the same antenna with the transmitting receiver is known with the antenna reciprocity. Antenna reciprocity is possibly because of the antenna characteristics are essentially the same as sending the receiving electromagnetic energy. Reciprocity of the antenna. In general, various properties of the antenna apply equal regardless of whether the antenna the transmitting receiver the more efficient if the certain antenna the transmitting the more efficiently it will be received with the same frequency. Likewise, the direction property of the given antenna also will be the same whether the transmitting or receiving. Assuming that for example, the certain antenna the transmitter radiates the maximum amount of the certain energy of the right angle of the axis of the antenna. The shown figure 4.7 the view A with the minimum amount of the radiation along with the axis of the antenna. Now the same antenna where you with the receiving antenna the shown view B would be received the best in the same directions. It would produce the maximum radiation of the right angle of the axis of the antenna. A transmitting antenna, minimum radiation, maximum radiation, maximum radiation. Receiving antenna, maximum reception, minimum reception. Antenna gain. Another character for the given antenna that remain the same as whether the antenna is used for the transmitting or the receiving of the gain. Some of the antennas are highly directional for the more energy the property given in certain directions. And the others, the ratio between the amount of the energy propagated with the direction compared with the energy that would be propagated with the antenna were not directional but known as the gain. When transmitting an antenna with a certain gain is used with the receiving antenna, it will also have the same gain with the receiving. Polarization. Let's review polarization review. Then chapter 2 of the review, we learned the radiation field component with the electrical magnetic line of the force. The line of the force will always be the right angles to each other. The intensity rise and fall together, reach of the maximum 9 degrees apart. The electrical field determine the direction polarization of the wave of the vertically polarized wave. Vertical line force alive with the vertical direction, horizontally polarized wave. Electrical line of the force alive with the horizontal direction. Circular polarization has the electrical line with the force rotating at 360 degrees each of the every cycle of the radio frequency energy. Electrical field was chosen the reference field because of the intensity of the wave, usually measured in terms of the electrical field intensity, volts, millivolts, microvolts per meter. When a single wire antenna is used with the extra energy of the passing radio wave, the maximum pickup of the result with the antenna is oriented with the same direction electrical field. The vertical antenna is used with the efficiency reception of the vertical polarized wave of the horizontal antenna is used with the reception of the horizontal polarized wave. In some cases, the orientation of the electrical field does not remain constant. Instead, the field rotates with the wave that travels through the space under the condition of both the horizontal and vertical components of the field exist. The wave that should have an elliptical polarization. Polarization requirements for the various frequency. Ground wave transmission widely used with the medium and low frequency. Horizontal polarization can be used with these frequencies pick up with electrical lines with the force are parallel and touch with the Earth. Since the Earth acts as a fairly good conductor for the low frequency, they would short out the horizontal electrical line force to prevent the radio wave from traveling very far. For electrical lines of force, on the other hand, are bothered very little by the Earth. Therefore, vertical polarization used with the ground wave, the transmission line with the radio wave to travel a considerable distance along the ground and serve with the minimum actuation. Your skywave transmission is used at high frequency. Each of the horizontal and vertical polarization called the skywave. The transmission because the skywave arrive at the receiving antenna. Elliptical polarized as the result of the wave traveling obliquely through the Earth's magnetic field. The strike in the ionosphere of the wave is given through the twisting motion of the strike of the ionosphere of the orientation continues the change of the unstable nature of the ionosphere with the relative of the amplitude of the phase of the difference between the horizontal and vertical components of the received wave also change. Therefore, the transmitting and receiving antennas can be mounted with the horizontal vertically. Along the horizontal vertical polarized antenna can be used with a high frequency of the horizontal polarized antenna. Certainly, the disadvantages are therefore preferred. That one advantage of the vertical polarized interference for signals such as proposed automobile ignition systems, electronical lines that minimize horizontal polarization. Also, a loss of absorption radio energy buildings wiring occurs when the antenna is used. Another advantage is used to support structure of the antenna are more convenient side of the vertical polarized antenna. All right, for frequency, the VHF and ultra high voltage, VH very high frequency and ultra high frequency range, either horizontal or vertical polarization satisfactory radio wave that travel directly with the transmitting antenna, the receiving the antenna without entering the ionosphere, but the original polarization produced with the transmitting area is maintained throughout the entire travel with the wave of the receiver. Therefore, the horizontalization polarized antenna is used with the transmitting horizontal polarized antenna must be used with the receiver. The requirements would be that the same the vertical transmitting of the receiver the antenna system. The satellite communication parallel frequency can be used with the interference by using the polarized radiation. The system sets up the shown figure 4.8 with the one parallel system satellite antenna is vertically polarized, another pair is horizontally polarized. Either vertically or horizontally polarized transmission required with respect of the antenna transmitted with the same polarization. For example, the transmission line may be made in 3.7 to 3.74 gigahertz range for the vertical polarization path, and the 3.7 to 3.76 gigahertz range the horizontal path without adjacent frequency co-channel interference. Show the filter 1 down converter vertical polarization, receiving antenna vertical polarization, transmitting antenna down converter filter 3.7 to 3.74 gigahertz transponder. Also 348 satellite transmission using polarized radiation. Show the horizontal polarization, receiving antenna down converter, then the filter 3.72 to 3.76 gigahertz transponder, the horizontal polarization transmitter antenna. All right, advantage of the vertical polarization. Simple vertical antennas can be used to provide omnidirectional, all direction communication. The advantage when a communication must make from the moving vehicle. In some other overload communications, such as the vertical installations, the antenna heights of the limited 3 meters or less, or 10 feet and less. In such instances, vertical polarization results with a stronger receiver the signal than the depth of the horizontal polarization and frequencies about with the 50 megahertz. From approximately 50 to 100 megahertz, the vertical polarization results with a slightly stronger signal than the depth of the horizontal polarization. With the antenna shame above 100 megahertz, the difference in signal strength is negligible. For transmission over the body of the water, vertical polarization may be much better with the horizontal polarization antenna for the lower height of the frequency, increase the minimum antenna height, the decrease for the 30 megahertz of the vertical polarization in meter, and better antenna height about below the 91 meters or 300 feet with the 8.85 megahertz of the antenna heights of about below 15 meters or 50 feet, still lower heights than the higher frequency. Therefore, the ordinary antenna mass height is 12 meters or 40 feet. Vertical polarization a disadvantage. Vertical polarization advantages of frequency less than about 100 megahertz. Radiation is somewhat less effective by reflection of the aircraft flying over the transmission path of the vertical polarization. Instead of the horizontal position shows the reflection of the cause of the variation. The received signal strength is a factor of the important locations where the aircraft the traffic is heavy. The vertical polarization used the interference to produce the pickup and become the stronger the Voltage, very high frequency, ultra high frequency broadcast transmission, television, or FM. They cover the very high frequency, ultra high frequency transmission due to the horizontal polarization factor is important when the antenna must be located in the urban area through having several television or FM broadcast stations. Advantages of horizontal polarization. Simple horizontal antenna is a bidirectional character for the desire to minimize interference with a certain direction. Horizontal antennas are less likely to pick up man-made interference with the ordinary vertical polarized. The antenna are located near the dense of the force among the building, the horizontal building wave that suffer off the vertical polarized wave, especially 100 MHz. Small change of the antenna located do not cover the large variation for the field intensity horizontal polarized waves. Vertical polarization, even the change of the few media for the antenna location may have the considerable effect with the receiver signal strength of the result of the interference before pattern of the producing the same wave within space of the wind and the spurious reflection from the tree of the buildings occur with the simpler antennas are either the transmission line with the vertical and is less affected by the horizontal amount of the antenna. The antenna is bound with the right angle of the transmission line with the horizontal polarization line is kept out of the direction of the field of the antenna. As a result of the radio pattern of the electrical character of the antenna, particularly unaffected with the presence of the vertical line transmission line. Radiation resistancy. Radiation energy is useful for the transmitter signal. However, the representative of much of the law for the antenna's energy law for the heating of the antenna wire. In either case, the dissipated power will equal the amperage squared over the ohms. In this case, the heat of the resistance, real resistance. In case of the radiation resistance is assumed to be is assumed to be resistance. The resistance energy. Resistant were actually presented with a dissipated small amount of the power the antenna takes for the radiation of the energy. Assume the resistance of the referred to as the radiation resistance. Alright, radiation resistance varies at different points of the antenna. The resistance always measures the current loop of the antenna. The free space of the entirely removed from any of the object that might affect its operation. The radiation resistance is 73 ohm of the practical antenna located on over the ground plane may have the any value of the radiation resistance of 0 to approximately 100 ohm. The exact value of the radiation resistance depends on the height of the antenna above the ground. Before the most half-wave wire antenna, the radiation resistance of about 65 ohms. The usual will vary between 55 and 600 ohms from the antenna constructed with the rod of the tube. The actual value with the radio resistance is such as 50 ohms or more has the little effect with the radiation efficiency of the antenna. This is because of the ohm resistance is about 1 ohm for the conducted larger. In dynamic, the ohmic resistance does not become important until the radiation resistance drops to a value less than 10 ohms. This may be because there are when several antennas are coupled together. This occurs. This may be caused when several antennas are coupled together. Or radiation type of the patterns. Energy for radiation with the antenna forms of the field without having the definition radiation pattern. Radiation pattern is a plot of the radiated energy from the antenna. The energy is measured with the various angle with the constant distance from the antenna. The shape of the pattern depends on the type of the antenna. Even in the section of the introduce the basic type of the radiation of the isotropic and anisotropic their radiation patterns. Isotropic radiation. The antenna source of the radiation equal to an all direction radiation of the type known of the isotropic radiation. We all know that the sun radiates the energy in all directions. Energy radiates from the sun measured with a fixed distance from any with the angle with approximately the same. Assuming the measuring device for the move of the ground of the sun stop at the points of the indicated by the figure 4-9 to make of the measurement of the amount of the radiation at any point of the round. The circular distance for the measuring device to the sun is the same. The measured radiation will also be the same. The sun is therefore considered isotropic radiator. 4/9 of the isotropic radiator. To plot this pattern, we will assume the radiation will is measured on the scale of 0 to 10 within that the measured amount of the radiation 7 until all the points. We will then plot all the measurements on the two different types of the graph. It's a rectangular polar coordinated graph. Rectangular coordinated graph of the measured radiation is shown view A with the figure 410 with a straight line with the plot against the position along the circle. View B shows the polar coordinated graph of the same isotropic source. Alright, 4/10 of the comparison of rectangular polar coordinated graph of the isotropic. Show the measured radiation over the position in the circle, the origin, the vertical axis of the radiation pattern, the horizontal axis, the polar coordinated graph. Rectangular coordinated graph. The graph is located with the projection of the pair of the stationary and perpendicular axes. The polar coordinated of the graph points are located with the projection along with the rotating axis of the intersection of the several concentric equal squared space is circled. Horizontal axis of the rectangular coordinated of the graph that corresponds with the circle. The polar coordinated graph of the vertical axis of the rectangular coordinate of the graph corresponds to the rotating axis of the radius of the polar coordinated graph. Rectangular coordinated pattern. Look at view A with the figure 410 with the number to position for the round of the circle are laid out in the horizontal axis of the graph of the 0 1/7 of the measured radiation laid out in the vertical axis of the graph of the 0 to 10. The units of both axes are shown in the pattern of the occupied of the convenient path of the graph. Horizontal vertical axis of the right angle with each of the point of the axis of the cross each other known with the origin. In this case, the origin is 0 on both axes. Now, assume that the radiation view value is 7 units in view B with the measure of them position 2. With the position 2 horizontal axis divided line of the projected upward of the run pair with the vertical half from position 7 on the vertical axis line is projected to the right of the run pair with the horizontal axis of the point of where the two lines across the intercept the represent the value of the 7 radiation until the points of position until units at position 2. This is the only point of the graph that can represent the value. As you can see, the figure of the line you allowed to plot the point of the rectangle. For this reason, the type of the plot is called the rectangular coordinated graph. New rectangular is formed with each of the different points of the plot. For example, the points applied within the line in a straight line. For example, the 7 units of the vertical scale on the projection of the position 7 on the horizontal scale. The character of the pattern, the rectangular coordinate with the isotropic source of the radiation. Polar coordinated pattern. Alright, your polar coordinated graph of the pad provides the grade with the U for the study of the radiation patterns compared with the view A and the U for the figure 410 with the greater difference shape of the radiation pattern when it's transferred from a rectangular coordinated graph of the U A with the polar coordinated graph of the view B with the scale of the radiation value with the both of the graph of the identical with the measure for the take with the both of the same now, but the shape of the pattern is drastically different. Look at the view 410 assume the center of the concentric circle in the sun, assume that the radius of the drum from the center of the sun, from the sun to the center of the circle of position 0, with the circle when moved to the position 1, the radius moved to point 1, when moved to position 2, the radius moved to point position 2, and so on. The points of the where measurement was taken the mark of the 0, the 7th of the graph now have the take of the position radius to indicate the actual direction of the source of which the measurement has been taken the distinctive value for the over the rectangular coordinate of the graph of the position indicated along with the straight line with the axis that has no physical relation to the actual direction of the movement. Now that we have indicated for the direction of the movement measurement, we must divide the way to indicate the magnitude of the radiation. Notice that the rotating axis always drawn from the center of the graph of the sun position of the edge of the graph of the axis of the toward the edge of the graph of the path of the set of the equal space of the concentric circle with an example of UB with a number successively from 1 to 10 with the center out with the circle of U with the indicator of the magnitude of the radiation advantage of the polar coordinate of the graph of the median with the evidence sort of which for the center of the observation circle is also center of the graph of looking at the polar coordinated plot of the radiation pattern. You can immediately see the direction circle of radiation put out by the source. Therefore, the polar coordinated graph is more useful than the rectangular coordinated graph of the radiation patterns. Anisotropic radiation. Most radiators emit stronger radiation in one direction than in another. Radiation such as referred to as anisotropic. Example: the anisotropic radiator is the ordinary flashlight. The beam of the flashlight is only a portion of the space surrounding it. If they circle the drum with the flashlight, the center of the shown view B with the figure of 411, the radiator of the light can be measured with the difference of the position around the circle of the ram of the isotropic radiator. All position the same distance from the center with a different angle. However, the illustration of radiated light is measured about 16 different positions on the circle. Or 411 shows the anti-isotropic radiator. Directly behind the flashlight, the position 0 of the radiation measured the minimum. According to 0 of the value of the sign of the position rectangular coordinated graph 4, your 411 view A of the radiation remains with the minimum until the position 4 becomes between the position 4 and 6 of the measured device center of the flashlight beam. You can see the transition in darkness with brightness easily with the view B of the radiation. Fairly constant between the 6 and 10 of the maximum brightness of the curve of the position 8 when directly in the path of the flash of the beam, from position 10 to 12 of the measuring device between the flashlight beam of the radiation measure will fall off sharply with the position of 13. The radiation again is 0 that stays at the value back to the position 0. Radiation light source of the radiation antenna both of the forms of the electromagnetic wave. Therefore, this measurement of the radiation antenna follow with the basic perceive that at this just described the sunlight and flashlight. Before you proceed further into setting antennas patterns, you should be surely understand the method of the graph of the measure of the radiation, magnitude of the radiation, study of the rectangular polar coordinated system plotted presented in this following section. Alright, figure 411 view A of the radiation pattern with the flashlight, the graph of the rectangular coordinate of the illustration flashlight beam with the view B with the clearly indicate with the shape of the flashlight beam. This is the not evident radiation pattern plotted on the rectangular coordinated graph. Now look at the figure 412 of the radiation pattern show the figure looks very much like an actual flashlight beam. The pattern in the figure 412 of the plot U with the same value of those figure 411 the view A with the drawn the U with the polar coordinates. Figure 412 shows the polar coordinated graph of anti-isotropic radiation. The position of the marked off the two polar coordinated graph of figure 410 and 412 were selected with the number arbitrarily. However, the standard method allows the position around the source to be marked to opposite of The one radiation pattern can be easily compared with the other. The measure is based on the fact that the radius of the 360 degree, the radiated extent of the vertically of the center of the position 0 of the figure 410 is designated 0 degree. Of the position 4 of the radius of the right angle 0 degree of the radius of the according to the radius position 4 is measured at 90 degrees. Position 8 is 180 degrees, and position 12 at 270 degrees. Position 16 at 360 degrees. The various radii drawn with the graph are all marked up according to the angle of each of the radius, making the resist reference over the 0 degrees. Radiation pattern field 4 12 of the same with the U the same with the perceived the U with the figure 4 10 the UB with the radiation measure with the point is 1 2 3 and 4 is 0. The position 5 makes the appropriate one mark. This mark on the graph the rotation radius move the position 6 at this point position the reading of the 5.5 unit is taken. Before making the point is marked on the graph, the procedure repeated around with the circular reading of those obtained with the making from position 6 to 11 as position 12 no radiation is indicated to continue on to position 16. The polar coordinated graph that now shows the definite area of the enclosed of the radiation pattern. The pattern indicates the general direction of the radiation from the source of the enclosed area of the called the lobe. The outside of the area is emitted, the radiation is emitted in any direction from the example of the position 2 of the radiation 0 at the point called the null. In the real situation, the radiation is usually transmitted in all directions. Therefore, the null is usually used to indicate the direction of the minimum radiation. The radiation, the pattern of the figure 412 shows the one lobe and one continuous null. Or your antenna loading. Well, you will sometimes want to use the antenna system for the transmitting and receiving several different frequencies. Some of the antenna must also be resonant with the applied frequency. You may need either physical or electrical length with the shortening of the antenna. Except for the trailing wire with the antenna of the aircraft installation, with which the length of the shortened physical lengthening of the antenna is not very practical, but you can achieve the same result by changing the electrical length of the antenna. Changing the electrical length, you can insert either an inductor capacitor in series with the antennas as shown as in Figure 413, view A and B, with the change of the electrical length of the method used in lumped impedance or loading. The electrical length of the antenna wire could be increased with the decrease of loading, and the antenna too short of the wavelength may be being used as a resonant high frequency that is being excited, therefore, but the capacitive reaction for the existence of frequency of the capacitive reactions can be compensated for and introduced in lumped inductive reactions shown in Figure View A. The simpler the antenna is too low for the transmitting frequency of the inductive reaction, the inductive reactions can be compensated by the introducing lumped capacitive reactions shown in View B. The antenna without loading is represented in Figure C. Alright, View A shows the inductancy. Loading and compensating to a short antenna. Loading and compensating with a capacitor to a long antenna. Normal antenna without loading. Alright, basic antennas. Before you look at the various antenna for the considerable relationship between the wavelength of the antenna being operative with the actual length of the antenna does not necessarily radiate the receive more energy when it is made longer. Specific dimensions may be efficient with the operation of the antenna. Nearly all the antennas have developed the two basic systems, Hertz and macaron. The basic for the Hertz of the antenna is 1/2 the wavelength along with the operating frequency isolated down from the ground. This is often called the dipole or doublet. The basic macaron antenna 1/4 wavelength and either the ground at one end of the connected to a network of wires called the counterpose. The ground of the counterpose can provide with the equivalent additional 1/4 wavelength which required for the antenna to resonate. Half-wave antennas. The half-wave antenna referred to the Dipole headers of the doublet with a consist of the two lengths of wire around the tubing with each 1/4 in the wavelength along with a certain frequency. The basic unit of any complex antenna with the given architecture with the half-wave antenna operates independently over the ground. Therefore, it may be insulated far above the surface of the earth of their absorbing by the dipole. For the current maximum center minimum at the end of the voltage, the maximum minimum and certain of the maximum ends of those well shown Figure 4-6. Radiation patterns. In the following discussion, then the term of the dipole, the U with the term team name, the basic half-wave with the antenna with the term doublet with the U with the indicate with the antenna with the is very short compared with the wavelength with the operating frequency physically with the in the same shape of the dipole. The radiation pattern with the doublet is simplest form of the practical antenna. The radiation pattern can be plotted like a radiation pattern with a flashlight. Figure 414 shows the relevant vertical horizontal position of the doublet, but this is not a picture of the radiation. Three-dimensional values of the pattern itself. The three views of the pattern resemble the doublet, but for the dimension of these views, the two types of polar coordinated patterns can be drawn. Horizontal vertical, a horizontal pattern view with the derived with a solid pattern view C, by slicing it horizontally produce the view B converted with the polar coordinates meaning of the view. A horizontal pattern illustrates the radiation constant in the direction along with the horizontal plane. Or horizontal pattern antenna, horizontal plane antenna, solid pattern, vertical plane, vertical pattern. Vertical pattern view E is obtained with the drawing with the vertical plane with the view D with the radiation pattern with the UC with the radiation of the pattern for the view C with the slide within half along with the vertical plane through the antenna to produce the vertical plane pattern with the view D. The vertical plane D with the radiation plane pattern differs the horizontal plane of the view B with the vertical plane of the view E. Exhibit the two lobes and two null. The difference of pattern with the two patterns is called the two facts. No radiation emitted at the end of the doublet and maximum radiation coupled come from the doublet in the direction perpendicular with the antenna acts at the top of the radiation pattern with the non-directional and the horizontal plane with the directional vertical plane. Alright, from the practical viewpoint of the double antenna can be mounted with either vertically or horizontally. Doublet shown figure 414, mounted with the vertically radiated energy speed that spreads out with about the antenna every direction horizontal plane. Since an ordinarily horizontal plane, usual plane with arrangement with the not is termed non-directional. Directional character of the antenna other than planes is ignore. The doublet will be mounted horizontally if it would be effectively turning in the pattern with the edge of reversing the pattern. Given the 414, the antenna would be directional in the horizontal plane. The terms directional and non-directional are usually convenience for the describing them specific radiation patterns. Complete description always involves the figure of 3 dimensions, as in radiation pattern figure 414. Alright, radiation pattern of the dipole. The radiation pattern of the dipole is similar with that of the doublet, with increasing the length of the doublet with the half of the wavelength of the equivalent with the flattening of the radiation pattern. The radiation pattern of the horizontal plane of the dipole larger for the circle of the doublet with the radiation vertical pattern. The loop is no longer circular, they are flattened, and the radiation intensity is greater. Horizontal plane antenna acts as solid pattern, vertical pattern. Our method of feeding energy through the antenna. Voltage and current distribution from the half-wave antenna with the same as the antenna that discussed earlier in the chapter. The plume with the closely related to the voltage and current distribution of the antenna. Method of feeding of the transmitter out to the antenna. The simplest method of feeding of the energy half-wave of the antenna to the half-wave antenna is to connect one end of the capacitor to the final output stage of the transmitter. This method is often known as end feeding or voltage feeding method. This method the antenna is fed by the point of the high voltage. Our kilovoltage distribution, half-wave length, amperes, voltage, standing wave of the current voltage. Energy may also be fed to the half-wave of the antenna, dividing the antenna into term of the connection, transmission the line with the final transmitter output stage of the two center ends of the half-wave of the antenna. Since the half antenna is not now being fed at the center of the point of the low voltage, high current of the type of the feed with the known the center feed of the current feed method. Point of the feed is important to determine the type of the transmission line to be used. Quarter wave antennas. If you have the top of the previous section, one half the wavelength is the shortest antenna that can be used with the free space. If the half wave of the antenna is the half thing of the ground, one end will have the ground quarter wave of the antenna. The antenna will resonate with the same frequency on the ground half wave antenna. Such that the antenna is referred to with the quarter wave of the macron antenna. Quarter wave antennas are widely used in the military. Most mobile transmitting and receiving antennas are quarter wave antennas. Show the two-wave communication to serve the emergency of the verticals, radio, telephone pole, the two communication point of data with the voices or voice to individuals. Central dispatch off of the transmitter received the one-way paging to individuals. As stated above, the ground quarter wave of the antenna will resonate with the same frequency of the underground half wave of the antenna. This will cover the ground with a high conductivity, acts as an electrical mirror image of the characteristic of the vibe of the missing half of the antenna shown at the bottom of the part of the figure 418. In other words, ground quarter wave of the antenna acts with another quarter wave mirror, actual down to earth. The quarter wave of the antenna, the image, and the image antenna, ground wave, quarter wave, image, half wave. Characteristic of the quarter wave antenna. The ground end of the quarter wave of the antenna has a low input impedance, low voltage for the high current with the input with the shown figure 418. The ungrounded end has high impedance, which for the copper the high voltage and low current with the unidirectional character for the ground wave. Grounded quarter wave the antenna is the same as over the half wave antenna in free phase. Explained with the earlier with the ground loss for the effect of the radiation pattern of the cover the high signal losses for some frequencies. Such losses may be greatly reduced if the pattern conducted with the ground is provided. Vicinity of the antenna, the perfect of the ground screen, the figure 419 view A with the counterpoise and the view B. The two transmitter conductor buried by the foot of the two below the surface of the basin flitter ground screen. Our ground screen and counterpoise, antenna counterpoise, for mounting connector and radials. Your ground screen in view A with the component with the sphere with the conductor of the buried 1 to 2 feet below the surface of the earth. The arrangement of the radial pattern with the conductor may be reduced to the loft of the ground with immediate vicinity of the such radial system of the conductor is usually one half of the wave of the length of the diameter. In counterpose view B with the U the way in which when assessed for the base of the antenna is necessary off the U with the either with the not good the conducting strip of the east of the ground sand the or solid rock. Counterpose strip of the the perfect of the ground screen usually elevated above the earth with no specific dimension necessary for the construction. Counterpose no number of the wires particular critical the particular counterpose may be assembled with a large screen or chicken wire with some similar material. The screen may be placed on the ground, but for better result obtained if the place a few feet above the ground. Alright, your folded dipole. When using parasitic elements for the various static range of the reduction of the radiation resistance of the 7 feet halfway within 10 or these conditions, obtaining the proper impedance for the matching between the radiator of the transmission line, but is often difficult. Conventional method of overcoming the difficulties is you fold the dipole and play with the center fed with the radiator view A and B of the figure 410. Ordinary dipole and then folded. Conductor 1, conductor 2, transmitter timelines and transmitter. Folded dipole is ordinarily halfway within 10 that has one or more conductor connected to the cross. That has additional conductor for the mounted parallel to the dipole element of the distance equal to the very small fraction of the wavelength space from the several inches is common. The feedback and impedance can be further increased with the 3 to 4 properly spaced parallel conductor standard feed line with the spreaders that are to maintain the spacing when required in the folded dipole. The increased impedance square number of the conductors using the radiator. Thus, the 3-wire dipole is 9 times the 3 or 9 times has 9 times or 3 to squared. 3-point impedance of the simple center feed dipole with the second method of stepping over the impedance folded dipole using the 2 conductors with different radii shown view B. Virtual character for the folded dipole same as those for the same simple dipole, but however the resistance of the reactance of the folded dipole varies more slowly than the frequency of the verified resonances because the folded dipole can be used over a much wider frequency range if possible with the simple diode. Alright, array antennas. Array antennas are special arrangement of the basic of the antenna with the component that involve the new fact of the component that before you study about array of antennas, you need to study some of the new terminology. Definition of the terms. An antenna is made with more than one element. The basic element is generally with the dipole. Sometimes the basic element is made larger or shorter with the halfway of the but deviation usually not greater. The driven element is similar to the dipole have to be instead of connected directly with the transmission line that obtain the proper directly with the transmitter. Receive the antenna deliver the received energy directly to receive the parasitic element is located near the driven element from which the gives the power of the place that belong with the driven element, the permanent coupling. Alright, parasitic element sometimes placed as what will produce the maximum radiation during the transmission from the associated driver the operator with the reinforced energy coming from the driver toward itself. The parasitic element is referred to as a director. The parasitic element is placed to cause the maximum energy radiation direction away from itself with the toward the driven element with the parasitic element called the reflector. And the elements of the array driven, the array is referred to as the driven array. That is sometimes connected array, sometimes as a connected array. If one or more elements of the parasitic of the entire system is usually converted as a parasitic array. Multi-element arrays frequently classified according to their directivity. The bidirectional array, the opposite direction along with the line of the maximum radiation. Unidirectional array rays only in one general direction. Arrays describe the respect of the radiation pattern of the type of the elements of which they are made. However, they will be find that you identify the physical placement of the elements. The direction of the radiation will respectively these elements. The general speaker for the term of the broadside array designates an array with which the direction of the maximum radiation is perpendicular with the plane of the containment of these elements. The actual practice for the term of the confined with the array in which the elements themselves are broadside with the parallel with respect to each other. The collinear array and then watch for the elements of the line with a straight line with no radiation at the end of the array, the direction maximum radiation, particularly the axis of the elements. End fire array is one with the principal direction of the radiation is along the plane of the array and perpendicular to the element. The radiation is from the end of the array, which for the reason for the arrangement is referred to as the end of the fire array. Sometimes the system uses the characters of more than one of the 3 types mentioned for the instance that some of the elements may be collinear, where the other may be parallel. Such arrangements are referred to as a combination array with an array of arrays. Some of the maximum radiation on the curve of the right angle of the plane of the array. The term broadside of the array is U with the front back, the ratio of the energy of the radiative with the principal direction, optimal of the energy radiative with the opposite direction given the antenna. Alright, phasing. Various reflective refractive component of the propagated wave creates the effect of the reinforcement cancellation. The certain distance point for the transmitter, some of the wave components meet, and then space of the reception of these points either impaired or improved. And then different components arrive at the given point with the same phase. The addition they add and make a stronger signal available. If they arrive at the out of phase, they cancel and reduce the signal strength. Radiation pattern. Effects of the similar to describe the preceding paragraph that can be produced with the transmitting point of the self-considered with the antenna shown figure 421. View A and B with the view A shown for the unstructured view of the radiation pattern with the single dipole with the view B of the 2 dipoles shown in the position points 1 and 2 with the particularity of the plane of the page of the base of the 1/4 length of the part with the operating frequency. Radiation pattern for either the antenna 1 or 2 of the operating alone with the uniform of the direction of the phase of the shown view A with the supposed that the current is being fed at both the antennas with the same transmitter in such a way that the current feed of the antenna 2 lags the currents of the antenna by 90 degrees, entering radiating with the antenna 1 toward the receiving location X will receive the antenna 2 after 1/4 cycle of the operation. The energy both of the antennas will add and propagation towards X will be stronger. Figure 421 shows phasing of an antenna's free space. X and Y, Y and Z, 1 and 2 show the 2 dipoles and B. Radiation antenna 2 toward the receiving location Y, which received the one after 1/4 cycle of the energy of the antenna 1 received 1/4 cycle behind the antenna 2 because to begin with there will be the radiation from the antenna 1 to receiving point Y will exactly 180 degrees out of phase of the antenna 2. As the result of the radiation field will cancel, therefore with no radiation towards Y. A receiving point away from the line of the radiation play for the difference between the core curves between 0 and 180 degrees, producing various amounts of the energy in the direction of the overall effect that is shown as the radiation pattern shown with the view B of the physical phase relation to the curve of the quarter wavelength space between the two elements, as well as the phase of the currents of the elements active chain with the radiation pattern of the individual antennas. Stub phasing. In the case of just described, the current of the two antennas with the same transmitter with the 90 degree phase section of the transmission line is called the subs. A frequent use for the purpose of the sub that can be adjusted to produce the desired phase relation between the connected elements. The two collinear half-wave elements connect with directly to there, so their currents are the same with the phase, the effect of the same with the full wave of the antenna shown in figure 422. View A, the current first of the one half wave with exactly 100 degrees out of phase with the second and one half wave with the opposite of the direction. The illustration move the arrows are used to indicate the direction of the current flow of the antenna. Use the arrows convention means to determine the phase of the more complicated arrays. Alright, your feeder line halfway meeting in the center. Feeder line shorted stub, quarter inch, quarter half wave, quarter the wave over the I don't know. With the two elements connected with the short of one quarter wave stub, that's a 1/4 wave stub. As I thought, shown the UB with the travel down one side with the stub down the other. The travel the distance of 1/2 the wave of the length of the stub itself. The result of the current level move through the 1/2 cycle of the chain with the current to reach each for the second element of the desired phase. The second current on one side of the stub equal with the opposite of the current on the other side of the field. Produced to cancel. No radiation is transmitted from the stub itself. Directivity of the antenna on the ray can be determined looking for the radiation pattern of the ray of the propagate for the given amount of the energy. More radiation take place within certain described direction than in the other elements of the ray that can be altered in such a way that they change the pattern distributed more uniformly in all directions. Elements can be considered with a group of the antennas from the comments over the facing with different directions. On the other hand, elements can be arranged so that the radiation would be focused in a single direction with no increase of the power of the transmitted, but the amount of the radiation given the direction would be greater. Since the input power there is no increase, but the increase of the directivity is achieved with the expense of the gain in other directions. Directivity and interference. In many applications, shape of the directivity is desirable through no need except for the added gain. But the physical disposition of the units shown in figure 423, transmitter 1 and 2, the sending information received the 1 and 2, respectively along the pattern shown with the solid area of the distance between the transmitter 1 and the receiver 1, but between the transmitter 2 and the receiver 2 is short, does not require high power transmission. The antenna transmitter propagates well in direction, however, the receiver 1 picks up some of the signal from transmitter 2, and the receiver 2 picks up some of the signal from the transmitter 1, show with the broken air with the effect of the side of the received antennas intercepting energy equal with well in all directions. Transmitter 1, receiver 1, transmitter 2, the receiver 1, transmitter 1, receiver 2, transmitter 2, the receiver 2. On the usually directional array of the radio of the transmitter tend to solve the problem of the signals are beamed along the path of the solid array to provide the long radiation along with the path of the broken air for the further improvement along with these the using arrow of the direction of the air of the receiver the antenna with the effect of the range for them to be selected with the direct desired signal while the discriminating against all other signals. The same approach that you use to overcome the type of the radiated the interference with some cover the prevention radiation in certain directions more the important to produce the greater gain in other directions. Alright, looking at the difference between the two field patterns of the center single element of the antenna array with the illustrated figure 424 of the UA with the show of the relative field strength of the pattern of the horizontal polarized signal antenna with the view B with the show of the horizontal radiation pattern with the array and antenna view A radiates fairly efficiently with the desired direction toward the receiving point X radiates exactly with the toward the Y with the no radiation desired of the direction antenna view D. View B radiates strongly with the point X, very little direction with the point B with Y, which result with a more satisfactory operation. Single antenna pattern, array pattern time, minor lobe, antenna, major lobe. Alright, major, and minor lobes shown in figure 424 of the UB with the radiation concentrated in two lobes. The radiation intensity of one lobe considerably stronger than the other. The lobe toward the X is called the major lobe, the other as minor lobe. Since the complex radiation patterns are associated with the array frequently contained with several lobes, the various intensities should learn to use the appropriate terminology. General major lobes are those which greater amount of the radiation occur with the minor lobes are those which radiation intensity is least. Alright, directional arrays. You have already learned about the radiation pattern, the direction of the radiation, the topics of the important with the because of the antenna, the proper the radiation pattern with the wrong, with the directive, the retrieve, the overall performance of the phone system. The following paragraphs will discuss more detailed various types of the directional array of the antenna array was mentioned briefly in the definition terms paragraph above. Alright, collinear array. The pattern radiated with the collinear array is similar with the produced with a single dipole. The addition of the second radiator, however, the 10 of the intensify the pattern with the compare with the radiation pattern with the dipole, view A with the figure 425 of the two elements, and 10 of the view B with the B. We'll see with each of the pattern consider the two major lobe with the opposite direction along the same axis of QQ1. There is little no radiation with the PP1 axis. QQ1 represents the line of maximum propagation. You can see the radiation stronger than the added element, the pattern of the view B, sharper than more directly than the view A, but this means that this is meant by gain of the line maximum energy propagation is increased, the beam width is decreased as more elements are added. The effect is heightened and shown that you see that the important minor lobes are great generated as more elements are added. One element, two elements, four elements. Okay, single half-wave antenna versus the two-wave half-wave antenna in phase. Alright, more than four elements or so of them be used because they accumulated off of the cover the elements farther from point of the feed left of the current for the near ones of the entry of the unbalanced condition system impaired with the efficiency, space limitation, off the end with another region, restricted with the number of elements to the top of the array with a single line rather than a vertical stacked arrangement that uses too many elements, the result of the antenna of several wavelengths long. Radiation pattern. The character for the radiation pattern given the array with the same with the frequency band with the frequency with the which for the system of the resonsivity of the day with the directivity character for the loss for the antenna not you with the near the frequency of the array with the tune with the sharper the collinear antenna is most effectively with the end of the fire array. And fire away when you the altitude, tune, frequency. The feature is considered a transmission reception that should be over the wide frequency band with the one more of the two elements or you the advantage largely disappear. Length and phasing. About one half of the wavelength is base for the collinear element. We'll find with the greater length of the often U, the effective array of the top of the has been constructed with the elements of the 7th to 8th of an 7th and even an 8th wavelength long. The top of the array provides efficient operation more than frequency over the wide frequency range. Whatever the length is decided upon, all the elements of the particular array should closely adhere to the length of the elements of the desired length of the combined current phasing distribution change. Throwing system of the balance and series of the effect of the radiation pattern. Or spacing, how the lower relatively efficient collinear array of the many elements compared with the multiple elements array relates directly to the spacing of the multiple impedance effect of the multiple impedances. It is an important factor to consider the two elements parallel to space with the considerable coupling between the very little mutual impedance become the collinear section with the variable impedance that does not exist with the coupling between the end of the adjacent elements, placing the end of the elements closer together, frequently necessary because of the construction problems, especially when the long lengths of the wire are involved. Or the effects of spacing advantage for the proper space for the demonstrate for some of the practical examples of the collinear array of the covering two half of the half element is 1/4 wavelength of the space between the center of the 1.8 decibels and the same this dipole is separated with the distance from the center of the approximately 3/4 length. They are driven in the same sort of the gain. They increase with approximately 2.69 decibels. Or the three dipole array with the negligible space between the element of the gain of the 3.3 decibels, the other with the word of the two other elements, the wider the space of the gain obtained with approximately equal to the gain obtainable with the three elements with close to the spacing. Spacing of the array permits similar construction spacing. Two diodes used to allow the antenna to occupy less space. The construction problems usually dictated small array spacing. Alright, broadside array. The broadside array is shown in figure 426 of view A. Physically locates some of the somewhat like a ladder where the array of the elements are polarized horizontally. It looks like an upright ladder. When the arrays are polarized vertically, lower laddering laying at one side of view B. The view C is an illustration of the radiation pattern broadside array. Horizontal polarized arrays are used more than two elements for the common because of the requirement of the bottom array. There's a significant difference above the Earth present with the construction problem to compare with our collinear arrays. Broadside array with the tuning sharply, loss effects efficiently, rapidly, will not operate the frequency within they are designed. Figure 426 the typical broadside arrays: A array, side view array, top view of the array. Or radiation pattern. Figure 427. I'm sure for the end of the U2 polar half-wave of the antenna of the A and B with the operating same phase located with 1/2 the wavelength of the point P with the removed from the antenna appear with the same single point with the enter energy rating from point P toward P from the antenna A sharp out with the phase with the energy rating of the point B from antenna B in the same direction. Propagation from each of the antenna travel over the same distance of the point B arriving in the phase of the antenna reinforces the H over there in a direction making strong singles available. The P field strength with the measure for the P is greater than what it would be. The whole power supply with both antennas has been fed. Single dipole radiation toward the point 1 is built up in the same manner. Or 427 of the parallel elements of the in phase. Now consider the wavefront toward the point Q with the antenna of the B with the time of the reach of the antenna of 1/2 wavelength. away. 1/2 cycle of the elapsed. Therefore, the energy of the antenna B of the me for the energy source of the antenna A of the 180 degree of the result of the energy moving toward the point of the Q for the 2 source of the center of the like a man with the radiation of the antenna, the travel to the point of the Q remits for the cancel radiation same direction of the antenna B. But as a result, little propagation takes place as either direction of the QQ1 exists. Move for the energy is concentrated in both directions of the PP1 axis. Both the elements for the antenna elements are already fed with the same sort of the restrictive of the basic broadside array. All right, when more than two elements are used with the broadside arrangement, they are parallel in the same plane as shown in Figure 426 of UB, with the current phase of the indicator of the arrows must be the same for all the elements. Radiation patterns Figure 426 of UC, they always bidirectional. The patterns are sharper than one shown in Figure 27 because of the additional two elements directivity gaining depending on the number of elements spacing between them. Our gain in directivity, the physical disposition of dipoles operated broadside, each other allow for the greater coupling between them. The curve of the collinear elements move with the parallel antenna eliminates closer together farther apart, the effect for the actual impediment, the entire array of the overall radiation resistance as well as the space between the broadside elements included the effect of the radiation pattern sharpening of the major lobe of the area. It consists of the only two dipoles spaced exactly 1/2 the wavelength apart. No minor lobes are generated at all. Include the distance between the elements beyond the point. However, the end of the phase relationship between the original component current with the one element and the current drifted into the other element. The result, although the major lobes are sharpened, the minor lobes are introduced, even though the two elements of these, however, no longer are enough to be concerned. If you had the same number of the elements for both the broadside array and the collinear array, the given broadside array will give greater to reduce the radiation resistance, resulting in efficiency coupling between the dipoles, accounting the most of the game. However, certain practical factors limit the number of elements may be used. The construction problems include the number of the elements, especially when they are polarized horizontally. All right, we're gonna cut the tape there, and